When we're simplifying radicals with multiple variables, it's helpful to look at the variables as numbers just to get an understanding of what's going on. So say I have the square root of x squared, and then I set x equal to 3. Well, the square root of x squared then would be the square root of 3 squared, which is also equal to 3 squared is equal to 9, so we say square root of 9. And we know that 9 is a perfect square. If we look on this multiplication chart, there's 9, and a perfect square is just one number times itself is equal to this number here, and that's a perfect square. Okay, so we can look at this square root of x squared like it's a perfect square, because we are multiplying one number times itself. Right? So then we can just take out that x, and this would be our answer. Just like the square root of 9 is equal to 3. Okay? I hope that makes some sense. Now let's look at something a little bit more complicated, not much. We've got x squared, y squared. What is the square root of x squared, y squared? Well, we just solved the square root of x squared and we got x. So the same is going to be true of y squared. It's just y times y. So we'll be able to take a y out from under the radical. Okay? So that's our answer. Let's look at another one. Get a little bit more complicated, but not much. We're going to do the square root of 100 times m cubed times n. I'm going to separate these so you can see them. You do not have to do it. Do whatever works for you. Okay? So, and I've got m cubed times n. Okay, so I've just separated the number from the variables. Hopefully you can see that 100 is a perfect square. And that's here on our multiplication chart. It's just 10 times 10. Okay, so we know the square root of 100 is just 10. So I can take that outside the radical, and I'm going to go ahead and write that answer down. Okay, and now I've got m cubed n, and I could rewrite this if I wanted to as m times m times m times n. Okay? And then I see, oh, there's an m squared right there. I know I can take an m out of that. So I can pop an m there. So I've got that taken care of. I've got that taken care of. And I'm left with an m times an n. Those are both to the power of 1. I cannot simplify them any more under the radical. I'm going to move this down just a little bit. So I'm just left with the square root of m times n under the radical. That's it. That is my answer. So hopefully you're beginning to see this. Let's do another one. Let's do -2 times the square root of 15 oh, that's a terrible 15. Sorry about that. Let's see. 15 a squared b cubed. I'm going to separate these just so you can see it, but you do not have to. Don't forget this -2. I'm going to bring that over. -2 times the square root of 15 times the square root of a squared b cubed. Okay, -2 is never going to change. It's always going to be out there. Unless we have something to multiply it by. 15 is 3 times 5. Both of these are prime numbers, and they are not, we do not have a perfect square anywhere in that number, so that's going to stay the square root of 15. All right, again, I need to bring this down a little bit. Okay, so under the radical, we're going to have the square root of 15. Now let's see what else we have. We have a squared, a times a. So I'm going to be able to take out an a, And b cubed, I've got b times b times b. So I've got a b squared times a b. So I can take out 1b, and I'm left with 1b under the radical. And that is the answer with a really long radical sign. Okay? Let's try one more. And feel free, obviously, to pause the video and try these out on your own. And I even after watching it, I would do it a few times until you actually absolutely have this down. Okay? So let's look at this one. I'm going to separate, again, I'm going to separate this 75 from the variables e to the 6th and f to the 5th. As a matter of fact, I'm going to go ahead and separate the e's and the f's individually. So I'm going to have e to the 6th, so I'm going to have 6 e's, and I'm going to have 5 f's. Okay, just to drive the point home about what we're doing. So 75 is 3 times 25. There's a prime number. And 25 is 5 times 5. Okay, there's 2 5s there, so I know I'm going to be able to take that outside the radical. And I'm going to give myself a little bit of room. And then, but I'm still left with this 3 here. So I can't forget, I got to put that under the radical. All right, now I'm going to go ahead and group all of these. I've got 2 e's here, I got 2 more e's, 2 more e's. So I know right there I've got e squared times e squared times e squared. When I take those out from under the radical, I get e times e times e. Okay, now I've got 2 f's here, 2 f's here, and I only have a single f right there. So I got to remember that. So I can take 2 f's out, and then this f has to stay underneath the radical. Okay, I'm almost done. Now I'm going to multiply these together, so I get 5 e to the 3rd, multiply these, f to the 2nd, times the square root of 3f, and that's it. So I hope that helps. Don't forget about your perfect squares, and go back to this if you need to understand it some more. All right, I really hope this helps. Let me know if it doesn't, and I will try to figure out another way to let you know. All right, I'll see you in the next one.